In this video, I will demonstrate how to complete a correlation hypothesis test. We will be using the data from problem 6 found on page 325 of our textbook. And I will let you take a look at that and so that you can read that over and understand exactly what that is asking. I will put on our webpage under week 5 the file that you see in front of you so that you can follow along if you'd like using an Excel file. Well, if you read the problem, we're interested in the relationship between alcohol abuse and drug abuse among incarcerated individuals, and so that's going to be our parameter. Specifically, the parameter we're interested in is the correlation coefficient, but I'm okay if you want to write it in plain English this way. The relationship between alcohol abuse and drug abuse among incarcerated individuals. So they specifically have been tested using some sort of a screening scale, and they have their alcohol score and drug scores listed in the table. The next thing that we're going to do is we're going to write down our hypotheses. And the null and alternative hypotheses will be the same for all correlation hypothesis tests. And the null hypothesis is that there is no relationship. And I'll just put this in parentheses, but you don't have to add this to your hypotheses, that their correlation is 0. Just to remind ourselves why we call this the null hypothesis. No relationship means no correlation, or correlation equals 0. The alternative hypothesis is that there is a relationship. And just to remind you, what that means is that there is a correlation. And that correlation is not equal to 0. Let me just get my not equal to symbol. The critical value is found on in the tables. I'm just going to pull up my table here. Let's see, where did I put it? There it is. And these are in the back of your book. It's table E. Let me zoom in here so that you can see what I'm looking at. There. So table E, whoa, went a little too far. There it is, table E, critical values for R. Degrees of freedom are n minus 2, the number of pairs minus 2. So looking at this data, the number of pairs of scores, I have 10 pairs of scores. 10 minus 2 is 8, so I have 8 degrees of freedom. And so let's see, 8 degrees of freedom corresponds with a critical value of 0.632. So you'll get that from table E in your book. So the critical value, 8 degrees of freedom. Let's see, this is R crit. It's the critical value for R is 0.632. Next, we'll compute the test statistic. And this is just a calculation using the worksheet function. Equals correl, and you highlight the arrays of numbers that you're interested in. So my test statistic is the actual correlation coefficient for this data, which is 0.649. And you'll notice that 0.649 is further from 0 than 0.632. And so the conclusion is that there is a statistically significant relationship. Oops, and we are rejecting the null hypothesis.